All right, so we're continuing ahead with more area under the curve kind of stuff. So I think it's like our third time already doing this. And basically means you have no excuse at this point, though, if you forget to do this, if you're running into something like this on the AP test. But you should understand by now that the integral is the area under the curve. So that's what's going on with this. The integral from -2 to 3 is going to be the area under the curve on the interval from -2 to 3. On that interval, we're going to find the area, and I wouldn't say under, they always say under, but it's between the curve and the x-axis, because we're going to find out about negative area in this lesson. That's where it's going to change. So if you're finding the area under the curve, this would actually be our area, which is technically above it, right? So, and that would actually be negative area, which is strange. We've never heard of negative area before, but with calculus, and we're talking about the graphs, the area under the curve in this case, the area would be negative because our output values are negative. So let's go ahead and take a look at this one. So we're going from -2 to 3. I don't know why I picked the same color as the graph. There we go, we'll use green. And so we can break this into shapes that we do know. That's what we'll go ahead and do. So that's a triangle. That's a 3 by 2 triangle. So its area is 1/2 3 times 2. So that would be 3. Then we have a rectangle, 2 by 1 rectangle here. So that would be 2 times 1 for that area. And then we have a 2 by 1 rectangle. So that area would be 1. And then we have a 1, not even 1. Well, wait, we stop at 3. That's right. So we're stopping here. We don't need it. I was looking at this little part right here. So 3 plus 2 is 5 plus 1 is 6. And that would be the area underneath that curve from -2 to 3. I believe, let me see this one. No, that one's fine. That's just more of the same. I was talking about area underneath is negative. Let me see if this comes up with it. This example does have negative area because we're underneath the x-axis. So in this case, we're doing, our lower bound is 2, our upper bound is 5. So we're going from 2 to 5, the area on that interval there. Now notice this is, I wouldn't say a half a circle, but a quarter of a circle. So what are we going to do? Well, it's going back to like what, 7th grade, just the area formula, area of a circle. We know the area of a circle. Area of a circle is pi r squared. So you just got to kind of, these kind of problems, it's the area underneath the curve. Do some thinking here. This is really when your critical thinking is going to come in, these skills. Calculus isn't that difficult a lot of times. It's these little questions that people get mixed up on. But right here, the integral of f of x is the area underneath the curve. Well, how am I going to find that area? Well, that's a quarter of a circle, right? If we continue that circle around, we just need a quarter of it. So that's the area of the circle. What's the radius? Well, that's halfway across the diameter, right? So the radius in this case is 1, 2, 3. So we get 9 pi. That's the area of the entire circle. So what would the area be of that quarter circle? We would just take it and divide it by 4. But remember, it's underneath the x-axis, so it's negative area. Well, what if it was a half a circle? If it's a half a circle, then you would do this formula and do half of it. If it's 3/4 of a circle, which would be strange, you wouldn't run into that, but you do 3/4 of it. So that's what I mean. Just use, in that situation, you got to think through these things. That's a lot of times when people are like, well, we can't use math in real life. It's probably because we're struggling to think through some of these basic things. It's these type of problem-solving skills you guys got to be able to do and figure that out on your own. I shouldn't have to directly teach this to you. You should just be able to, at this point, go, -5 to -1. It's a half a circle. I know that the area of a circle, you start somewhere. You start with the area of a circle is pi r squared. And maybe it's going to take you time to get to this kind of thinking, where you can do this stuff on your own. But the point is you start pushing towards that independence in a sense. So we're starting with the area of the circle formula is pi r squared. From here, it's like, okay, what is r? Well, r is the radius. Our radius here is 2. So that's pi times 2 squared, which is 4 pi. And we want half of the circle. And sometimes we forget these things to take half. I'll be honest, there's times where, I'll make those kind of little mistakes. Just be careful. So that's 2 pi. I can't even draw 2. Nope, still not working. So 2 pi, and it's positive because it's above the x-axis. We're actually going to learn that if we integrate backwards, it flips it around, and we're going to talk about that, I think, in the next lesson. So there you have it. 4 pi would be the whole circle, so we only want half of it, so we cut that in half. And that's pretty much it. If you did have, let's just say you had some area above and some area below, you would just do the area above minus the area on the bottom. You just basically add the two together. And that's pretty much it.